Okay, for today's topics, I'm circling back to something that was a little previous involving these static variables and static methods, which we kind of skipped over because I wanted to emphasize instance variables and instance methods. Those are the main things that we use in component objects. And with some of the examples, I hope you're starting to get a sense of how this object stuff works. And then there's this cute little composition example that the book has. But first, I need to, I want to finish, at least to a certain extent, some of what I was talking about last time, which is, if you remember this, we're taking this course class and expanding it to have this array of these module things. So this is an example of, now we have two classes working together, and this is an example of aggregation. Now, as you can kind of tell, unfortunately the terminology for composition, aggregation, association, all that, it's kind of a bit fuzzy. So I'm not gonna be making you responsible for applying the right terminology for, is this association or aggregation or that isn't the important thing. It's really the concepts that are important here. So the concept here is that that a course will consist of a number of these modules, and it's being represented in the course as this array, because that's really all that we have at this point. As we'll discover later in the course, a Java array is actually a little too, it's not the ideal data structure for this. But we don't have the mechanism yet to kind of do it a little better. So on the other hand, it is a useful example in how to use a very limited structure like an array. Java arrays are very limited in the sense that once you create one with a certain number, then you're stuck with that. But the situation here is we need to be, if we're creating a number of different courses, how many modules does it have? We want to allow the possibility it can have as many as you want. In the book, they say, well, we're going to not allow any more than 20. And for me, that's even that, while most courses aren't going to have 20 modules, in my opinion, there's really no need to set an arbitrary limit like that. And the reason they did was because with an array, because we can only have so many in an array, they say, well, we'll make 20 and that way we'll have as many as we'll ever need. Well, that's Murphy's Law says, when you say, I'm never going to need any more than this, that you're going to need more than that. If you kind of read ancient history, the original PCs had 64K of ROM. And the reason they did was because they thought they would really only need 32K of ROM. And so, but they said, well, let's double it, and you'll never need any more than that, ever. Well, guess what? That's K, not even, that's kilobytes, not even megabytes. So things were really, really tiny. Back then, your iPhone just kind of blows these out of the water. But again, if you think you're never going to need any more, you're going to need more. The very first hard drive that I bought, I was debating between 10 megabytes and 20 megabytes, and this was megabytes because we're going from kilobytes to megabytes. I thought, so I went with 20 because I would never have to buy another one. So yeah, so it's, that same principle applies here. So the book said 20, arrays only size 20. So how do we deal with that? And if you remember, a way to deal with that is to say, well, there are actually two things we're dealing here. One is, if my array of modules, in this case, my array gets filled up and I want to add another one. Now in Python or JavaScript, you just kind of bang it in and no problem. But that's because, well, there are lots of good reasons why arrays are fixed like this. So what can you do? What you can do is you can say, well, let's make a new array which is bigger, and then copy all the old stuff into it. Now, it would be a useful exercise to kind of do all that by hand, but fortunately, actually, Java provides a static method called arrays.copyof, and that what you do is you, actually, this should, yeah, this really should be that. One of the things to kind of watch out for is when you have some code and you do that refactor encapsulate fields things, there's like a checkbox that says, replace them all with the getters, and that can kind of screw you up a little bit. Anyway, so what this does is this here. What we're doing is I'm saying, if my module count, which is keeping track of how many I actually have, which is almost always going to be less than the size of the array, in this case, my strategy is I'm just going to add two to it. Actually, what I should really do is let's double it. That's actually okay. So I'm going to double it, copy, and what this does is this copies them all in. I double it, and once I double it, I have lots of room, and I leave them out there. So here, and then the other. This is what's called lazy instantiation, and this says is that I'm not going to instantiate my modules until I actually need them, and then just to kind of emphasize this hand expanding array thing, is I'm going to just instantiate it with one, and then. So the first one will go in, and then as soon as I try to add a second one, then it'll have to expand. And then just to kind of try that out, let's see. Well, what's sort of another? Okay, all right. So so here I'm creating a course. And then I'm testing this out. I'm adding these modules, and then see what I get. Oh, before I do that, the other thing, and the book for some reason is not good about this either. So I guess, I mean, by and large, I like the book, but they're when you have a getter for an array, in 99.99% of the time, you want to return a clone of the array, not the array itself. And the reason, well, can you tell me the reason? Encapsulation. Exactly, it violates encapsulation. Why? Because if you just do this, and this is what the refactor encapsulate fields will do this. If I get this, notice it's returning the reference to the actual array itself. And remember how object references refer to the actual thing itself. And so if I just say get the modules, all of a sudden I have my hands on the internals of this array. And if I say, okay, now set module 1 to this other thing, then it will change it on the inside of this. On the other hand, okay, what does clone do? Every array has a clone method which returns a copy of, a shallow copy. So what it does is it essentially does what we what we did up here, except that it returns a copy in a new array. So that where are you? Okay, so if I get a clone of this, now I have a separate object. And if I can change those to my heart's content, and it's not going to affect this instance variable. So this is a really important little thing. Okay. So all right. So let's see what. And then the easy thing to do, of course, is to return all of the whole array. So let's see what that looks like. So now notice that here, okay, for a couple things have happened. One is that I verified that my expanding array kind of worked. I initialized it with 1, and then I doubled it to 2, and then I added a third one and had to double again to 4. But then notice that now if I print the whole thing, then all of a sudden I have this null business here. Okay, so what that says is that I really don't want all of these. I just want the ones that I put in. So instead of this, and this is where I can use my arrays, my copy of range, it's copy of range. And the range, and this, so what does this do? It does what this is I think this is a well-named method. It returns a copy of the range of these, and actually it takes the module. It will return 0 through the module count, and the way these generally work is the origin is inclusive and the upper bound is exclusive, just like as we saw in random. So remember, module count is always going to be module count is always going to be kind of one more than the index of the array because of the off by 1 business. And you've heard me complain about the zero-based indexing. And the thing is that you have to pick your poison. And the poison I recommend, is at least the one that I've picked, is zero-based indexing is ridiculous, but we're stuck with it. So like even in the book, in this example we'll talk about tomorrow, where it's like, okay, I want to go through 1 through 100, but if I have an array of size 100, it goes from 0 to 99. So what do you do? Well, what the book did is, again, you pick your poison. The other poison is you create an array which is 1 more than however many you want, and you skip over the 0 index. That's dangerous too, because if you have an array of objects, that zero-based thing is going to be a null, and Murphy's law says at some point you're going to refer to it and try to invoke a method on it. So again, it's a matter of picking your poison. So all right, so let's try this out. Okay, now notice that I only have the 3 that I put in. Okay, and it's a copy. So I get the best of both. Now, when we talk about the collections framework, they have Java has a very rich set of classes that kind of do what the arrays in JavaScript and Python do, which is they expand automatically, but they're also type safe. And that's okay. Now there's a little bit more with the module and the assessments and stuff like that. I'm not going to go through it here. What I'll do is I'll put that code in and push it up so that you can kind of look at it. But that really is kind of the I think kind of most of what I wanted to kind of get out of this particular example is in there. What we have also done in the process, though, is notice that this is an example of a static method. And what I want to be clear about today is that there are kind of two flavors of variables and methods. There are instance and static, or class. So basically, to declare a static variable with the appropriate modifiers, and kind of we'll talk a little bit about what that's about, to be able to reference a static variable, declare a static method, and invoke a static method. We've pretty much done all that. And then there's this composition example I want to go through. So here's the thing to understand, is that with instance variables, there's one copy of an instance variable per object. So if I have a class and I've defined instance variables, and I create 10 objects, then there are going to be 10 copies of each instance variable. But a static or a class variable, there's only one copy per class. One copy per class. Okay, so that's one difference. They're declared using the static keyword. And static is an unfortunate keyword. They had to choose one. Class would be a better keyword, but they've already used class to define a class. Static is, the reason I say it's not the best keyword, because it doesn't really describe what that is. In other words, there's nothing necessarily static about it. In fact, we're gonna see an example, if not today, at some point, where a static variable is going to change values. So static usually means fixed, but a static variable is in fact a variable, and it can change. The exception is if we declare it to be final. So either instance variables can be declared final, static variables can be defined as final, and there's a use case for that we'll talk about. The other key difference to understand is that instance variables are associated with an object, so we invoke them using object.instance variable. And the thing is that with instance variables, we almost never want to do that. There are like a handful of exceptions. Like one exception is the length of an array. So arrays arrays are objects. They have an instance variable, which is the length of the array. So why is that okay? Why doesn't that violate encapsulation? Well, it doesn't, only because arrays are, that's a final variable. In other words, that can't be changed. So even if I get that, I can't do anything about it. I can't change the value. I can't set the length of an array, the length variable, to be something else. So that's sort of okay. So that's the, just in general, for any instance variable that you define, they shouldn't be accessed that way. But but static methods, static variables, you would refer to them by the class name dot the variable name. So, and actually an example of that, enums are actually an example of that kind of thing. So for our die type, this is the name of the enum, but an enum is really a type of class. So it's the class name dot the variable name. And a static, you can have any one of the 4 access modifiers. It would be public, private, protected, or package. The convention in most, but not necessarily all cases, is uppercase separated by an underscore. So instance variables are camel case beginning with a lowercase. Static variables are uppercase with an underscore. So if you see a variable that's all uppercase in Java, then it should be a static variable. The big use case for this is constants. So if you declare something to be static and final, then, and those are typically made public, typically. They don't have to be. But for example, in certain calculations, you want to use pi. Okay, what's pi? 3.14, goes on forever. I saw a meme where there's the kind of a pi is sitting at a computer and is trying to fill out a form. It says, enter your full name. He's going on forever. So in Java, they have math.pi. So if you ever use pi, you should use this because this will always give you the same value, and it's a pretty. Another one is integer max value. Like, well, what is the maximum value of an integer? Well, that is specified by this constant number, and it's public, it's static, it's final. So now, one thing, and well, maybe I'll do this. Okay, so here's the number of courses created. That would be now the way that the book does it is a little bit different than what I prefer. But let's here. Let me show you the use case for that. First, I'm gonna let me commit this here. Just see the commit is like it's like voting in Chicago. Vote early and often. So that at least locally just kind of saves all those changes. So if I screw something up, I don't have to lose what I've already done. So here's the idea. The idea is that now in this case, that's kind of the way the book does it, but I'm going to do it a little bit differently. I'm going to define something called next ID, and then I'm going to add an instance variable called ID. This is a very common pattern that I like to use. Now, and it's actually okay. Now, for instance variables, the book says it's sort of okay to initialize them when you declare them. For me, that's not good style. The instance variables should be initialized either almost always in the constructor and otherwise as we did with the modules in a special method. Okay, so the idea here is that okay, and then I'm going to have a getter. A getter, but no setter. Oh, where do we put it? Let's put it at the last method, private, public. Yeah, see, I use accessors even. Okay, all right. So every course is now going to have a unique ID, and here's how we do it. What we do is we have, So, okay, so now what does this do? What this says is that the next ID for this course, when I instantiate it, is going to be the value of the static variable. So next ID is a static variable. There's going to be only one of them, but every new course I create is going to have its own ID. And let's see, where's my toString? Number and let's add. So let's see, print the course, and then let's Let's print let's print it out again. Okay, so what I'm sort of testing this out here. And so here, the first one I created had ID 0, the second one I created had ID 1, etc. So what that does is that creates a unique ID for each of these. And actually, Java provides a unique ID called a hash code for each one. The problem is that hash code is this kind of weird number. And a lot of times you just want to kind of know what's, have one that just goes 1, 2, 3. And now, if you don't like the zero-based indexing, and there's no reason you should, we just initialize it to 1. And now they're going to go 1, 2, 3. So it's a little, and you kind of get to pick it. So this is an important example to notice how the difference between a static variable and an instance variable work here. So there's only one of these, because one of these per class, but there's one of these for each object. Okay, so now we've seen some example of these static or class methods. And so now even the instance methods are associated with an object. And so we invoke them using object.method. So we have a reference to the object dot the method. And that's true whether we're inside the class or outside. So inside the class, what it does is if we don't specify it, it's going to be this. Again, another name I don't like, but this refers to this object. Which object? This object. Not this object, this object. Okay, but static methods, again, are associated with a class. And so we invoke them using the class name dot the method. And we've seen that in this arrays thing, copy of range. Remember, in the die type, we had this values method that would return a list of all the different, this is true for all enums. They have a values method that returns a list of all the different the enums there. We declare it using the static keyword. And so just to kind of circle all the way back to day one, if you remember, one of the first things that we wrote in Hello World was system out println. So why all this stuff? Why not just say print or println? Well, here are all the different pieces. So system is a class. Okay, now we now know that out is a static final variable for system, and it turns out to be of type print stream. So system out, so this is a class. This is an object. And so println is an instance method of print stream, and how do we know that it's a print stream? Well, where'd you go? What happened? This shut down. Okay, how can we do that? Well, we can show the Java doc. And the Java doc, okay, there's println, but where'd you go? Let's show the Java doc for system out, and we see that it's a print stream. And print stream is a very useful thing for if we're dealing with texts and stuff like that. Okay, so now all has been revealed about what exactly is going on here.
Sir,
Yes.
is it just convention that out is
Uh, yeah, yeah. I mean, if you're strictly following it, yes, it should be all caps. Um, Historically, what happened is that well, the people who write Java made the rules, and so they decided they can break the rules. So, but yeah, um, and there are, if you kind of look at the source code for Java, there, and even the source code for the libraries and stuff, they violate the rules all over the place. You know why? Because it was written by a team of people. Java itself is written in C, and so these are like actually C programmers who are writing it, and you can see a lot of C-isms in the Java source code, unfortunately. So, but, and the other thing is that this was around since Java 1.0. I mean and sort of a lot of things they learned a lot about how the thing works since then. So but there are some anachronisms. Okay, so now it's important to understand what is visible and what isn't. So within a class, all instance methods see everything within the class. So they can see the instance variables and they can see the static variables that are defined within the class, regardless of visibility. They can see the instance method, they can invoke the instance methods or the static methods within the class, regardless of visibility. So if you declare a static variable to be private, then the instance variables inside that class can still have access to it. They can still refer to it directly. Now, a public static variable can be referred to outside. So like with like here, these are examples of public static final variables. If it's public, it should be final. So we can see that anywhere. You know, math pi, integer max value, all these are, everybody can see those, but if they were private, they could only be seen within the class. It doesn't work the other way. Static methods only have access to static variables, not instance variables. Static methods, but not instance methods. That is just directly. Why? Because with an instance method or an instance variable, you need an object to refer to that. And a static doesn't have an object. Now, what you could do is within the static method, you could create an object and refer to it using that object. But the method itself can't. Do you see all that? Okay. Now the book has this kind of cute composition example. So this is why is it composition? Well, because you have these classes that actually they're these tiny little classes that just kind of it's a cute little example though of how to put together a number of different classes and a number of different instances of those and produce an interesting result, I think. You know, again, you wouldn't. Okay, so so remember our Boolean operators. So we have double ampersand is an and this is true if I have two. If they're both true, then I have that. The double pipe is an or, and it's true if either of the conditions is true, and if one of them, if they're both false, it's false. If one is true, it's true. And then the exclamation point is or not is the condition false. And so what they were, so they have these things called, you know, and you're probably more familiar with these than I am, but one type of wire diagrams kind of use these different components. So we have AND gates that take two inputs, two binary inputs, and then they'll output a binary output depending on what the inputs are. So if you give it two zeros, it'll give you a 0. If you get a 0 and 1, it'll give you a 0. A 1 and 0 is 0, or 1 and 1 is 1. And the OR gate works like an OR, where if it'll give you 0 if they're both zeros, but it'll give you a 1 if at least one of them is 1. And then finally, the NOT gate is that if I give it a 0, it'll flip it to 1. If I give it a 1, it'll flip it to 0. So you see, with respect to these binary deals, it's kind of operating in a similar manner. And so in this cute example, let's create classes for each one of these. And in order to kind of represent this, we're going to just represent each of these as an instance method that's going to say, we're going to give it the two, say for an AND gate, we're going to give it 2 integers, and then it's going to return an integer. So if we get, and the logic is going to be the same as this. So and then similarly, for an OR gate, we're going to give it 2 integers, it's going to give us 1, and then for the NOT gate, we give it 1 integer. So let's see. So let's so if you do a pull, you should see CS2173.logic, and this is where these have been implemented. So here's the AND gate. Now here's the thing: is that it would be nice if there was a type that was just like a bit type, and the bit was just 0 or 1. Java doesn't provide that, and so it's possible that that you might, what if they give you an integer that's not 0 or 1? I mean, because that's the only rule of this. So so what I'm doing here is I'm just saying, okay, if you give me an integer and it's not 0 or 1, I'm going to use a bit operator to AND it with 1, and that'll just pick off the lowest bit. So if I give it just a number that's not a 0 or 1, this will just pick off the lowest bit. So if I give it a 1, it'll give me a 1. If I give it a 0, it'll give me 0, etc. And so as an AND, so here's a way to do that, is that I can say, if the first input is 1 and the second input is 1, I'll return a 1, otherwise I'll return a 0. So here I'm using that ternary thing. And then similarly for the OR gate, I'm doing a similar thing in terms of just kind of trapping making sure that regardless of the type of input you give me, I'm going to make sure I'm only going to deal with the bits. And so now it's like, if I say, okay, if either one is 1, it'll return 1, otherwise 0. And there are other ways of representing this, but I'll leave that to you. And then the NOT gate is going to be very similar. And here I did sort of a, oh, this is, probably my C roots are showing on this. The thing about C programmers are just as I said, the prime directive of the approach that I'm encouraging here is clarity of the programmer's intent. And so that sometimes means writing a little bit more, being a little more verbose than one might. For C programmers, the object is to show anybody reading it how clever and smart the programmer is. And so you want to write, like a single, the joke is that a good C programmer can write a compiler in 1 line. It's also called write-only programming, where it's like you can write it, but you can't read it, and nobody can understand it. So that's, this suffers from that a little bit, but okay, just had one of those days. So, this will take the input. I'm going to pick off the bit, and I'm just going to subtract 1 from it. So if it's a 1, it'll return a 0. If it's a 0, it'll return a 1. That's probably too cute. So now, just to to sort of how do we test these. So we'll create one of each of these, and this is more or less what the book does. And so I'm going to buzz over a for loop for each one of them, and print what I get there. So just kind of run that. So okay, so this is important because this verifies that each of my classes is actually doing the right thing. It's, testing is absolute. I can't just assume because the code looks right that it'll actually be right. So for the AND gate here, if I give it a 0 and a 0, I get a 0, 0, a 1, a 1 is 1. Okay, so that's for the OR gate. I got 0 is 0, and then every else is 1. And then for the NOT gate, I give it a 0, gives me a 1, give it a 1, give me 0. So that's just, I'm just verifying that each of these things worked. So the cutesy thing now is this thing called a half adder, and in other words, okay, what is that? Basically, this is kind of a low-level type of thing. That's this is usually implemented way down in the hardware, and the idea is that if I add 2 bits together, I'm going to get a result, which is 1 bit, and then a carry, which is going to be. So in other words, the idea is if I, again, just think of bits. Like if I have 0 plus 0, that's going to be kind of 0. If I have a 1 and 0, that's going to be 1. 0 and 1 is going to be 1. But what happens to bits if I add 1 and 1? Well, 1 and 1 binary is like 1, 0, 10. But here it's like the result is going to be 0, but then I'm going to have to carry the 1. That's kind of the idea. So that's basically what this is. So if I give it a 0 and a 0, it's going to give me a 0 result and a carry of 0. Whereas if I give it a 1 and a 1, I'm going to get a 0 with a carry of 1. And if I get a 1 and a 0, I'm going to get a 1 with a carry of 0. So now how can you implement this? Well, this is where these little circuit diagrams come into play. So it's like here's an AND gate, here's an OR gate. So what this says is I'm going to take each input, I'm going to give them to an AND gate, give them to an OR gate, and then the AND gate is going to give me the carry, but then the result is also going to go into this NOT one, which is going to go into another AND gate together with the outcome of the OR gate, and then that's going to give me the result. Now, somebody came up with this. I never would have been able to come up with this. So now the UML diagram kind of looks like this. So in other words, in order to implement this, what do we have here? We have 2 AND gates, 1 OR gate, and 1 NOT gate. And so to implement this in code, again, from the design point of view, we would have there's the 2 AND gates as instance variables, an OR gate and a NOT gate. And then the other instance variables would be the result and the carry. So the idea is that we would set the input, and then we could get the result and get the carry. And this is an example of composition, hence the filled in thing. And again, using these little diamond things and little squigglies at the end. I mean, that's sort of cutesy. The important thing is less that as it is the relationship here. In other words, this class uses instances of these classes. That's sort of the key concept here. Okay, so I got 5 minutes. So, all right. So what does that look like? So here's how that looks like. We directly from our UML diagram, you just sort of copy. I mean, the advantage of these diagrams, the UML diagrams, is that now they're sort of less. I have to do less thinking. All my thinking was done. Actually, the book did the thinking for me, but it was all done in creating this. Once I created this, I just sort of translate these over. Now, it isn't listed. Usually, in these UML, if there's only the zero argument constructor, I usually don't list them. Sometimes I do, sometimes I don't. It's kind of optional. But that to me is the ideal place to instantiate your objects. It's not in the word declarations. But here's sort of the input, and this is where I also pick off the bits, and then okay, here's implementing this thing. So here's the carry AND gate. That's this one right here. And so I get that output, and that goes right to the carry. So that's that line right there. Now for the other one, I have the OR gate. Okay, so the OR gate, I'm going to get the output of that, and then I'm going to put that through the NOT gate when I get the output of the carry gate, of the result of the carry, and that's going to be the result. And so let's sort of test that, and one way to test it is to give it every possible input. So 0, 1, 0, 1, I'm going to go do a double nested loop. And so if I give it the input 0, 0, the result is 0, carry is 0, check. So if the input is 1, and okay, well, if it's 0 and 1, then the result is 1, the carry is 0. If it's 1 and 0, the result is 1, carry 0. And if it's 1 and 1, the result is 0, and the carry is 1. So that checks with all of these. Okay, and so what's the lesson here? The lesson here is that, okay, here's another cute example of using, composition, or really just the association of objects, classes to each other. And so we're able to kind of create this cute thing. Okay, so now the next example, I'm going to spend a little bit of time on it, because it's even though it's kind of like a little game, and it's not, now I mean, if we had more visual stuff, we could kind of make a little thing, but that would be a lot more than we really need. But in section 7.3, they have this snakes and ladders game, and that's a nice example of a whole bunch of classes and putting them all together. And now there are some places in there where I have a different opinion about how it should be designed than the book. But overall, the book has a good, I mean, it's not bad, but I'm just kind of a little anal that way. So kind of, if it kind of does it a little different. So for example, there it's like you start on square 1, you need to get to square 100. I mean, that's arbitrary. In Java, we're gonna use a 0. So he has this. He kind of contorts the array, which to me is a dangerous thing. So instead, we'll say, what's wrong with starting on 0 and ending up on square 99? I mean, that's just as arbitrary as 1 to 100. So that's what we're going to do. And I will see you then.